So has everybody with me or not? I'm ready for any questions. Professor Fu is with me? Yes,
Yeah.
he appeared.
Hello.
Yes.
Hey, any questions?
I know things. I always convey a lot of messages. I know it's not easy. It's not like traditional course, even elasticity course. But once you get used on what is going on, it will be your life. And I have been working with boundary elements now since 1990. So how many years? By this year it will be 34 years or something like that. I have never changed it, and I will never change.
I think the singular integral it's very important.
Yes.
The issue in the
Yes.
boundary element method. Yeah. So
I started
I think
today.
yeah.
I started today to give some notations, some ideas about it, but believe me, we will take at least one lecture totally for singular integrals. And we will use that Taylor series expansion. You can use it for everything. Okay, and now I have a question now. A question appeared. Question appeared from, thank you for your wonderful lecture. I have a question. If it is a smooth concave boundary, is it also applicable when dealing with conceptual source? Yes. As I said, excuse me, Professor Lu. As I said, we computed the matrix when we have xi on a smooth boundary. But still, when we have xi on a corner or something like that, we can compute the matrix. It will be in terms of this angle. It's very simple. Instead of having your integral from theta equal 0 to theta equal 2 pi, it will have your angle. For example, if it is something like that, so you will have your integral from theta equal to theta 1 to theta 2 or something like this. So you will have a certain value for the internal angle. You can interpret it in terms of this angle, theta dash or something like this. So instead of your integral from 0 to pi, it will be integral from theta 1 to theta 2. And you have to define theta 1 by negative now and theta 2 by all of this. Another point also is much better to remember it. You can formulate your C matrix or jump term when you have your xi moved as internal point to the boundary, and you add your integral equation. You will have u of xi plus integral equal to integral. You compute the jump term and add it to this term. Or you can compute it as xi is external point. And now you have integral equal to integral with 0 jump term. And you move xi from outside to your internal boundaries. For example, this is internal boundary here. Okay? Then you will have your point, you cut off this half circle from here, and by that time you will have here you appear minus 1/2. Now it will appear 1/2, and you will add it direct here to have the jump term direct. This interpretation is much better to this one, because the mathematicians, they like to have smooth integrals. They call it Lyapunov space or something like that. Smooth integrals, and then you move the points from outside to inside. When I wrote my paper about hypersingular integrals, I used this interpretation, much better than this one. But mathematically, it is a bit difficult. It's not a bit difficult. It's somehow a bit difficult. It's not clear like the other one. Because for demonstration, I prefer to start it with this interpretation much better. Okay? So it's applicable. It's applicable. And if you find in the papers, if anybody interested to compute the C matrix with corners or something like that, I can send it direct to him direct. Okay, just ask me on WeChat and I will send it to you. Okay. Another question.
Now it's actually it's not question. Just
This
thank
is not
you.
a question. This is closing up for the question. Okay. Any
Yeah.
other question? Again, I'm ready at any time. Just send me on WeChat or WhatsApp or anything you like, and I will write my answer direct to you. I enjoy doing this. I always communicate with students here in Egypt, even undergraduate student, reply them direct. I write to them the explanation, take the photo, send it to them together with voice message to explain all details inside it.
Yeah. The professor, I would ask if the possible you send me a CV with the details things, and as I told you, I would like to try some
Okay, just send,
cooperative
if you can
projects.
send me email, tell me what exactly you want, I will reply direct to you. Okay.
Okay. So yeah, I will send an email to you.
Sure,
Yeah.
sure.
Yeah.
Okay.
Yeah.
Now
Okay.
one more question, then we will say thank you. Thank you,
Yeah.
everybody.
Okay. Thank you.
Okay.
Okay,
See you
bye.
next week. Bye.
Yeah. See you next week. Yeah. Bye.